To the Layer7 October Office Hours. I know it's not Halloween yet, but one day away. I just want to say happy Halloween to those of you who do celebrate it. For today, we do have a presentation that's going to be given both by Ben Urbanski and John Martin. It's a joint presentation on Layer7 and Gemfire. Just a quick reminder, right? You are all muted, but I'm going to unmute you. What that means is during the presentation, you will be able to take yourselves off mute and ask any questions that you may have. There's also a section in the panel where you can type your questions in. If you prefer to type your questions, that's fine. We will take time, of course, at the end to review all the questions and answer them. Also, one quick thing, there is an attachment in the handout section, and you can download it. What it is API Days in Paris in December is coming. So there's a registration link in that handout. And if you're interested, if you're in that area, you are a customer and you're in that area, please register and let us know. We do have some free passes. I'm not going to say we have enough for anyone and everyone that's interested. So if you are interested, hurry before we run out of our free passes. But we do have some. And it is in December. So it's December 9th through 11th, API Days in Paris. All right, so with that, I'm going to turn it over to Ben.
Thank you, Pam, and thank you everybody for attending today's office hours. Today we're going to be talking about Layer7 and Gemfire together. Beginning with John, who's going to give everybody just a quick overview of Tanzu Gemfire in general before I take over and talk about how Layer7 is working together with Gemfire to deliver certain key Layer7 capabilities to you. And we'll wrap up with a demonstration demonstrating some of those capabilities in action. John?
Awesome. Thanks, Ben. Hey, everyone. John Martin. I'm the product manager for Gemfire. And if you're not familiar with Gemfire, Gemfire is an in-memory data grid that's used for high throughput, low latency applications. Some of the key features from Gemfire is it's a key value object store. It's memory oriented, so it's memory biased, so all the data is kept in memory, which allows us to get that data faster, right? And so what that means is it ends up being about 10 to up to 100 times faster than relational databases because we're not pulling data from disk. It's horizontally scalable and elastic. It has a share nothing architecture, meaning that each node in Gemfire has its own data, it has its own CPU, it has its own memory. It's a Java-based application. You can scale it to 1 petabyte. You can write to a database asynchronously behind Gemfire. So it's a really great application for those high throughput, low latency applications that you need for speed. So one of the key features from Gemfire is its consistency model. So Gemfire has strong consistency. And what that means is when you have a client application and it writes data to Gemfire, we make sure that that data makes it to all the nodes that need that data. So if you have a primary copy and 2 secondary copies, we make sure that that data is put on all of the nodes that need that data before we reply to the client to say, yes, we have your data. And what that means is that any client that goes to get that information from Gemfire, we make sure that it has the most up-to-date and accurate information across all the nodes. So the difference is in an eventual consistency application, what you might see is a read or a write to the database makes it to some of the nodes, and a client may come in and get the data from a node that has not been updated yet. And so you can get inconsistent data that way. So we provide a strong consistency model within the Gemfire cluster. And then we do have eventual consistency with if you're transferring data to a secondary cluster offsite or when writing to the database in like a right behind pattern. And then next slide, Ben. So Gemfire is also availability zone aware. And what this offers us is zone aware clustering and fault isolation. What this means is you can set up a Gemfire node in this example, availability zone 1, 2, and 3. When you put your data into Gemfire, what that means is you can have a primary copy on availability zone 1. And if you have 2 redundant copies of your data, Gemfire makes sure that we put those redundant copies in AZ2 and AZ3. What this allows us to do is that if for some reason you lose your primary copy in availability zone 1, you still have the secondary copies in AZ2 and AZ3, allowing you to get that information from your clients. So you don't lose any service, and your clients and applications can continue to run. So if we look sort of beyond that, what that allows us to do is you can have a Gemfire cluster in this example in North America, in Europe, and in Australia. And so we have this active support, allowing you to synchronize your data across all of those sites. It gives you that fault tolerance. We can do bidirectional WAN gateways. And what it really does is it also allows you to say, if you have a lot of data in North America, but due to, let's just say, GDPR regulations in Europe, you can filter what events get sent to and from those sites. So we also have a lot of flexibility if you want only specific data to go to different clusters in different regions. So Gemfire is also elastic and scalable. So what this means is, in this example, we have a 3-node cluster. Let's say during holiday peak season, you need to grow your cluster by 1 or 2 nodes for a short amount of time. Gemfire you can add a node, and due to the share nothing architecture of Gemfire, because it uses its own CPU and memory, you can quickly spin up a new Gemfire node, add it to the cluster, it joins the cluster, your data gets distributed across all of those nodes. You can handle that peak consumption or that peak spike in your traffic. And then when that season is done, or when that time period is done, you can then take that node away. So you can then utilize your computing resources in a way that works for you, as opposed to always having to have it scaled up or scaled down or right size it from the very beginning. So how do we achieve that low latency? One of the pieces that we do, or one of the ways we do that, is our Gemfire client is a data aware client. And what that means is when a Gemfire client connects to a cluster, it goes to a member of the cluster that we call the locator. Now the locator is sort of the coordinator. It sort of knows where all of the servers are. It knows where the data is, and sort of your buckets of data are. So it sends that information back to the client. So now the client knows what servers are available, and it knows where the data is on each of the servers. So when you go to put data or get data from the server, it quickly can go directly to the correct node. It doesn't have to ask each node and go through each node to find that data. So that gives us a lot of that low latency, because we can, it results in a lot of fast transactions by knowing where and how to get that data. Another key piece of Gemfire is we have cluster-wide function execution. So Gemfire allows you to push your application to the server side. So this allows you to have applications that run on the Gemfire data nodes. So your application or your function runs right where your data is. That allows you to then not have to send data, all the data back to your client. So you can save the bandwidth. And so it runs, at the same time, it runs concurrently across all of the nodes, sort of in this map reduce function. And this allows you to then send back only the data that you need for your client applications. Each function operates on each local member, and then you can push that code and that data back to the clients. And so that gives you additional speed if you need only specific information and functions run on your server side. The other piece is, so while Gemfire is an in-memory data grid, we do offer the ability to have persistent storage. And so this is good for instances where you need to potentially bring down a cluster for maintenance, or if there's some sort of disaster recovery issue that happens, we have the data stored on disk. And so it's optional, but you configure it per member. And so Gemfire allows you to then say, okay, I have all of my data. I can have multiple persistent storage on each member. I can have some members that support it and some members that don't have it. So it really is flexible for whatever configuration that you need. It allows you to overflow. So if you have let's say you're sending data through to another cluster, and you have a queue that's lined up with multiple events that need to go over. If for some reason that queue fills up, you can then overflow it to the disk and store it. So again, we don't lose that data. So that's the goal of the disk persistence, is it allows you to make sure that we don't lose your data, and that if there's an issue, we have that data and we can recover quickly. So Gemfire, we have a lot of different applications that our customers are using. This is, a small sample of what that is, but you can see in financial services, we have customers using it for trade execution, fraud detection. So every time, for example, you would swipe a credit card, that transaction goes through a system, and that system can check for an anomaly, and it uses Gemfire to see, is this transaction fraud? Is somebody using it in a way that they normally do? Is the pattern the same? Balances and reporting for financial reports. In healthcare, we have customers using this for care coordination. So if, for example, you have a doctor who prescribes a prescription and you have a specialist that's working with you on some issue, and the two are conflicting, we have customers that are taking that data and making sure that the prescription, doesn't have any adverse reactions to whatever the specialist is applying to the patients. Claims processing, patient record access. If you're quickly needing to see, like, is my claim covered? Is it not covered? I know a lot of healthcare industry folks have that issue, right? You want to quickly look up, like, here's the code. Here's how, Gemfire is used for a lot of those instances. In logistics, inventory management. So monitoring, inventory in real time across locations. This allows for like proactive restocking, in peak seasons and things like that. Fleet tracking, so making sure that all of your vehicles, are they meeting their ETAs? Are they where they're supposed to be? How do we reduce, time going from location to location? So through geolocation data, Gemfire offers that ability. And then in terms of travel, real-time ticketing. So we have some customers who are using it for like train ticketing, and they'll have, they'll run specials some days where they get, hundreds of thousands of requests in a matter of minutes, and Gemfire handles all of that with the idea that we don't want to double sell the same seat. Luggage tracking. So there are some airlines that use Gemfire for making sure that your bags make it onto the plane, and then when they come off the plane, making sure they make it to the right place for you to go pick up your bags. So those are just some of the applications that Gemfire is used for. But overall, there's a lot of applications you can use Gemfire for. It's a really great tool.
Awesome. Thanks, John. I wish that last use case could make sure someone else doesn't take your luggage from the baggage claim, like happened to me this weekend, and we had to track.
Oh, no. Oh, no.
All right. Well, thank you for that, John. Now we're just going to cover Layer 7 and Gemfire. So why Gemfire, right? As many of you know, we've long supported Hazelcast as a distributed shared state provider, both embedded and external. We more recently added support for Redis as an alternative to Hazelcast, but only external. Why Gemfire? And here are the reasons why. First of all, it's a Broadcom product that we can give you together with Layer 7 and will be supported by Broadcom, right? So no more third party. It supports all of the use cases that both Hazelcast and Redis support combined. Those different solutions are limited in different ways across all those use cases. Like Hazelcast, but unlike Redis, it can be embedded. Like Redis, but unlike Hazelcast, it does support multi-site. It's going to be included with a new Layer 7 bundled SKU with some restrictions. We'll get into what those are. We at Layer 7 are not planning to charge you more for the Gemfire that we'll include with that bundled SKU. We just want to give it to you as another Layer 7 capability. I did say it will be given to you with a new Layer 7 bundled SKU with some restrictions. From an embedded Gemfire perspective, it's going to be embedded in every gateway, and there's going to be no restrictions based upon our SPD but there are going to be restrictions based upon implementation and scale. We look at the embedded Gemfire as being an adequate replacement for what embedded Hazelcast is used for. However, we're allowing it to be used for all of the other use cases that we have not let you use embedded Hazelcast for, but mostly as a convenience, because embedded Gemfire is going to share the processing resources of the gateway. So we really aren't going to recommend it or even support it for most of those use cases at scale. If you're having performance problems at scale when using embedded Gemfire, we're going to tell you you should go and use external Gemfire instead. One key capability that embedded Gemfire won't support is multi-site. However, with a new Layer 7 bundled SKU, you will have entitlement to also download and deploy and get Broadcom support for external Gemfire. That SKU is in the process of being created. So we just released Gemfire with Layer 7 as a preview capability in an 11.1.3 release that came out at the end of last month. It will also be part of 11.2, which will come out at the end of next month. You can start using it embedded with those versions or later of the gateway right away. If you're already a Gemfire customer and you have Gemfire deployed, you would be able to connect those versions of the gateway with an external Gemfire instance right away. But if you want to download and deploy and use external Gemfire with Layer 7 for the first time, you'll have to wait till we do create that new bundled SKU, which we're in the process of doing now. It should be available soon. And then you'll have to move to that SKU, either with a $0 contract between renewal cycles or at the time of your next renewal to get the entitlements you need to actually see Gemfire on the support portal so that you can download it, and to get support for Gemfire related problems if you want to go to support and open a case, right? Also, Gemfire is restricted in our SPD such that external Gemfire can only be used with Layer 7. You can't make other application connections to that external Gemfire instance to use Gemfire independent of Layer 7, or even to use Gemfire together with Layer 7, right? So the Gemfire you're going to get with the new Layer 7 bundled SKU only allows you to use it with Layer 7. And you're only able to deploy 32 cores of Gemfire for non-prod environments and 32 cores of Gemfire for prod environments total. So it doesn't matter if you get one Layer 7 bundled SKU license or 1,000, you're still capped at 32 non-prod, 32 prod. Now, how did we come up with 32? We did that based on our benchmarks, Gemfire benchmarks, to arrive at a sizing for a single Gemfire deployment in those environments based on 4 nodes with 8 cores. That gives you a 3 for a quorum, which is something Gemfire needs. It needs 3 members in a cluster, either locators or cache members, locator or cache members, to form that quorum, plus 1 for high availability. If you have use cases where you do need to have other applications connect to those Gemfire deployments to share data with Layer 7 or completely independent of Layer 7, or if you need more capacity than 32 cores non-prod and 32 cores prod, then you'll have to come back to Broadcom to buy more standard Gemfire licenses to be able to deploy more Gemfire for those purposes. So how is Layer 7 using Gemfire specifically? It's using it as a distributed shared state provider for these Layer 7 assertions, some of which are new or enhanced based on recent work we did for Redis, some of which have been available for a long time, first supporting Hazelcast, then Redis, now Gemfire. Gemfire supports all of these assertions. When you configure Gemfire to be used for these assertions, you can use it for some but not all. You can use Gemfire together with Redis and Hazelcast for different combinations of these assertions, but a given assertion or set of assertions that share the same system property can only use one of those three. And so configuring a gateway to use Gemfire for any of these assertions starts with identifying the right system property to specify what provider you want to use, and from a Gemfire perspective, whether that would be embedded Gemfire or external Gemfire. For the apply circuit breaker assertion, it has two system properties. If you're going to use, and the bottom line is the value for those must match. If you're wondering what embedded Hazelcast has solely been used for up until now, it's the last three assertions. I will say most of this presentation focuses more on Gemfire now than specific nuances for the different assertions that use it. Some of them do have nuances based on whether you're using Hazelcast, Redis, Gemfire, or otherwise. So go read their documentation, right? What might a Gemfire deployment look like? This is sort of a high-level logical deployment architecture where in the future, the portal and OTK might also take advantage of different distributed shared state providers, including Gemfire. Right now, it's mainly the gateway that still embeds Hazelcast as the default, so that with 11.1.3 and 11.2, there's no change there unless you optionally choose to replace it with embedded Gemfire. But it does embed Gemfire, and the gateway also now supports connecting to external Gemfire and Redis and Hazelcast. Now, like I said earlier, external Gemfire does support multi-site, like Redis, but unlike Hazelcast. However, embedded Gemfire does not support multi-site. Multi-site's important for customers primarily that want to share throughput quota counters across multiple data centers to have a single throughput quota worldwide, for example. Some of the other assertions will work with multi-site, though, I guess I'd say we expect to see that list. Others simply won't work with multi-site based upon how they're designed to work and network latencies. So throughput quota should work with multi-site. Rate limit, perhaps less so, especially if you're trying to rate limit within a 1 second duration. Though now that we're supporting 1 minute durations for rate limits, you might see some benefit there as well. So from an embedded Gemfire perspective, Gemfire is now embedded with all of our gateway form factors, both containers and appliance gateways and software gateways. However, it gets deployed a little bit differently between containers and appliance and software gateways. From a container perspective, each container gateway will have a Gemfire cache member embedded in it, but we deploy the locators externally. And there's a variety of reasons for that, but there's also some benefits, that come with that as well. From an appliance and a gateway perspective, every gateway has both a cache and locator member. As John was saying, and as we say here, locators are really used for discovery and load balancing between Gemfire clients, which the gateway is one of, and the different cache members in a Gemfire cluster. Again, as said before, I'll say it again here, it bears repeating. I think the next slide dives even a level deeper on this. Gemfire does need a quorum of 3 or more members, either locators, or cache members. So we have a lot of gateway customers that are 2-node gateway cluster customers, right? Those are our smaller customers, to be sure. But a single gateway, depending on the form factor and how it's licensed in size, has a lot of capacity. So many of our smaller customers have only needed 1 gateway for capacity, 2 for high availability, a 2-node gateway cluster. Now, right away, I guess I'll start with the last bullet first. That's fine with container gateways if you only deployed 2 container gateways and you had 2 locators deployed outside of them, you would have a quorum of 4. If you lost one of those members, if you lost one of your container gateways, the Gemfire cluster would still have the quorum of 3 that it needs to operate correctly and recover correctly. But if you're deploying appliance or software gateways and you lose one of your gateways that has both a locator and cache on it, that leaves you without a quorum. So it's important to understand that if you're going to choose to take advantage of this Gemfire capabilities with a 2-node gateway cluster of appliance or software gateways. It works, it's not highly available. What'll happen is one of those gateways will be a lead, the other will not be. And then you have these different scenarios. And in some cases, you know, where the lead stays up, but a non-lead goes down, not a big deal. The lead will keep processing and you can auto recover from that. But in the other 2 cases, there will be a problem, and one of which that you can't recover from unless you restart all your nodes. So just be aware, if you are going to use embedded Gemfire with appliance or software gateways, and you only have 2 of those in a cluster, you know, you need to consider these things. John talked a little bit about Gemfire functions. Not only do they deliver all the benefits that he talked about, but they also allow you to customize the behavior of Gemfire for specific use cases like Layer7 has for Gemfire. So we did have to create some Layer7 functions for Gemfire. Those are automatically bundled with embedded Gemfire, so you don't have to think about them if you're using embedded Gemfire. But if you do deploy external Gemfire and connect Layer7 to it, you also have to download from, you know, a Layer7 Gemfire functions jar from us and deploy it to your external Gemfire instances. And those functions would be used by those 4 different assertions specifically. So if you know you're not going to use external Gemfire with those assertions specifically, you don't need to deploy the functions jar. I would just do it anyway. If you deploy it but don't use it, no harm done. That way, if someone decides, hey, I'm going to use it with one of these assertions later, the functions are already deployed. Right? Gemfire also has a concept of regions. We create those automatically for you with embedded Gemfire, but when you deploy external Gemfire, you do need to create the regions that will be used by Layer7. All of this, by the way, is part of our documentation. We do document a lot of the uses of Gemfire with Layer7. At the same time, we didn't want to repeat all of Gemfire's documentation. So there'll be links to Gemfire. And if you're going to start to use Gemfire with Layer7, especially if you're going to deploy it and use it externally, you're also going to be going to the Gemfire documentation to learn how to do that based on best practices, for example. These are the defaults. When you create regions, we create a region per each of these different providers. When you create a region, it has to be of type partition. There's different region types that Gemfire supports, but that's what we require. And then you can specify redundancy. That's how many other regions your Gemfire data will be copied to. You'll see that for some uses of Gemfire and the assertions using Gemfire, we don't recommend redundant copies. For others, we recommend 1 or more. And that really has to do with how short-lived and or critical the data in Gemfire is. Without redundant copies, it's faster. But you could periodically lose data if you lost a Gemfire member and then at a particular time. With more copies, it's a little slower because Gemfire does need to do a synchronous write to all the copies for consistency, as John was talking about, but it's more resilient. One reason we do like Gemfire better than Hazelcast, for sure, less true of Redis, is the security that comes with Gemfire. There's different security features that we've implemented, including username password authentication when making Gemfire connections. That does require another jar that does need to get deployed when using external Gemfire. It's bundled with embedded Gemfire. There's additional properties that you need to configure on your Gemfire servers after deploying the jar. Those two things have to be done before you start up the Gemfire server, but they're typically things you would do once. Not only do we support the username password authentication with connections, but we also support connecting gateways to Gemfire over TLS. All of those things are things Hazelcast did not support. Redis did, depending on how you can, which version of Redis you had and how you configured it. We do support encrypting passwords using OpenSSL, like we've done for some other features where you might need to persist those passwords at rest. And so there's documentation for how you do that if you prefer to encrypt those passwords. Again, unlike embedded, external Gemfire does support multi-site. The primary use case for this is supporting, sharing throughput quotas across multiple sites. So across multiple data centers around the world, for example. From a layer 7 gateway perspective, that's all transparent to us. You would deploy and configure external Gemfire in those multiple sites to share the data between those multiple sites. Their layer 7 gateways would be just connecting to Gemfire within one of those sites as far as layer 7's aware. I will say that as of now, there's a known issue with multi-site, with throughput quotas across multiple sites. We've made some great progress on that in the last days. I would expect an update to come out at least with 11.2.1. if not sooner for a customer required it faster than that, where we're going to get better data consistency across sites. A few other considerations, you configure Gemfire client connections in a single shared state client YAML file like you could do for Redis. Again, we're going to have some documentation, but we're not going to repeat all of Gemfire's documentation. So as you start to adopt Gemfire, especially when deploying Gemfire externally, you will be also referring to Gemfire documentation for many things. From a comparison perspective, we do like to think that Gemfire is going to be a better alternative to Redis and Hazelcast combined. Again, by several different measures, beginning with you can get it all from us and with some restrictions for free, and we will support it. So, one throat to choke, as they say. You would open your support cases for, if you're having a problem using Gemfire with layer 7, you would open a support case to layer 7. And then what would happen behind the scene is the layer 7 support team would say, this is a problem with Gemfire, and it would get transferred to the Gemfire support team. So you're getting the best support possible for the product that is exhibiting the problem, all from Broadcom, but behind layer 7 support, which you as layer 7 customers are going to be most familiar with. Again, like Hazelcast, Gemfire, but unlike Redis, Gemfire can be embedded. Like Redis, but unlike Hazelcast, Gemfire supports multi-site. From a performance perspective, as John mentioned, Gemfire favors consistency with synchronous processing. There's definitely value in that, but because of that, it can sometimes be a little bit slower than Redis, especially for use cases that you would configure to have more redundant copies for, as we talked about previously. Redis favors performance and availability over consistency with asynchronous processing. So it's going to generally be a little bit faster, but possibly at the cost of data accuracy, right? Which does matter, especially for some of your use case, assertions and use cases that use them. So Redis might be a marginally faster than Gemfire in some cases, but both Redis and Gemfire are much closer to each other than all of the other alternatives. So Gemfire is still much faster than either using the gateway database or Hazelcast, where some of those assertions support one of those. I will say from a legacy rate limiting perspective, nothing is faster than legacy rate in-memory rate limiting on the gateway, but that's because the gateway's tracking those rate limits in its memory, not sharing that state across gateways. There's definitely reasons why you would want to use distributed rate limiting using any of these three state providers. And in that case, Gemfire is going to be faster than Hazelcast. The assertions each have documentation. In some cases, there'll be notes in the assertion documentation specific to Gemfire or Redis or Hazelcast. So if you were going to start using Gemfire with assertions, definitely look at the assertions documentation too to make sure that there's anything you should be aware of. But we also have just generalized documentation for Gemfire with Layer7 and Layer7 tech docs in terms of how to connect to Gemfire, whether that connect to, configure and connect to, whether it's embedded or external. And again, our documentation will often link to Gemfire documentation, and Gemfire has its own set of product documentation as well. So with that, let's cut over to a quick demo, show you some of these assertions using Gemfire in action. This shouldn't take too long, and then we'll leave some time for questions at the end. So I am running 2 ephemeral container gateways in a Kubernetes environment. So this is one of my gateways. This is another one of the other gateway. What you won't see here is a MySQL pod, so that helps indicate that both of these gateways are ephemeral and they're not sharing a MySQL database instance. So that also means that for all of these assertions that we're going to demonstrate using Gemfire, they have no other way to share their state between them except using Gemfire, right? And because this is a container gateway deployment using embedded Gemfire, you also see the 2 Gemfire locators that get deployed as part of that. When you deploy container gateways to use Gemfire, either using our Helm charts or the Layer7 operator, again, every gateway will have a Gemfire cache member embedded in it. But we will only deploy 2 external Gemfire locator members, and so you're just going to see the 2 by default. I'm also port forwarding from my laptop to this Kubernetes environment. I am port forwarding to this container gateway pod that ends with FWVDM on localhost 8443. And I am port forwarding to this other gateway that pod that ends with TGSRL on localhost 8444, which then inside Kubernetes forwards to 8443 on that container gateway. And so this just allows me to connect with Policy Manager to one or both of these gateways in this on my laptop, but also send other commands to those gateways or Gemfire as we step through the demonstration. Let's now go to Policy Manager, and I will connect to one of those gateways. And again, these 2 gateways don't share a database. So for this demonstration, I have a single service that has a policy that exercises some of these different assertions using Gemfire. And my service is called Gemfire. It's listening at /Gemfire. And I deployed this exact same service to both gateways. So both gateways have this service running on them. And what its policy will do is, first of all, it's going to use the apply circuit breaker assertion. which in turn will use Gemfire to share circuit breaker state between multiple gateways that are all connecting to the same Gemfire instance, right? Up until 11.1.3, our apply circuit breaker assertion only worked, only persisted its circuit breaker state in gateway memory. So that means if a event would open the circuit on a gateway based upon number of failures that gateway, policy failures that gateway was monitoring, or back-end latency that gateway is monitoring, then only that gateway would know that its circuit's open. And if you're balancing load across all your other gateways in the cluster, the other gateways would have to catch up with that. If you're sharing that state now using Gemfire like we do here, right away the other gateways are going to be aware that the circuit is open and they're going to behave appropriately. There's no catching up that is needed. In this case, I'm going to open my circuit. If any of the child assertions in it, if there's any failures in the policy, well, the child assertions of it more than 5 times, okay? So what child assertions are in it? I'm just setting a context variable that I will display later in my response, saying that if I got this far, then my circuit's closed, right? The circuit has not yet opened. And then I'm applying a distributed rate limiting and applying a throughput quota, both of them using Gemfire. So my distributed rate limit is limiting requests to 5 per minute using embedded Gemfire. My throughput quota is doing the same, also using embedded Gemfire. If my circuit is, my apply circuit breaker fails, then that means I've exceeded its threshold and now the circuit is open. So then I go ahead and set that same context variable to open. Again, I use that in my response. The other use cases I'm going to show here, well, the other use case I'm going to show here is external key value storage using Gemfire. This is also a new assertion. We introduced it with Redis. It supports Hazelcast, Redis, now Gemfire for storing key value pairs, and is meant to replace our tactical remote cache assertion over time for customers that have been using that. So what is this policy doing? When this service receives a request, if the request is accompanied with a store query string parameter with a value equal to true, then it goes ahead and it creates a message that includes the pod name and gateway time, and it caches that message in Gemfire. In every case, it looks to see if a message has already been cached. And then I return this response so that from the command line, as we send requests to the service on one gateway or the other, we can see how these things are behaving. Either it will succeed or fail. It'll tell you which gateway pod the request is being processed by. It'll tell you whether the circuit breaker state is closed or open. It'll give you information about the distributed rate limit that you're applying, the throughput quota that you're applying, and it'll show you if it found data that was cached by one or the other gateways. So let me go back here now, and we will go to this display here, where in these two smaller panels on the right, I've got a couple curl commands prepared to send a request first to the one gateway listening on localhost 8443. When I do that, I get back that response. I haven't triggered the circuit breaker threshold, so the circuit's still closed. It was my first request, so I still have 4 requests remaining for my 1 minute duration rate limit. And we present the same information for quota, but a little bit differently. The current count is 1 and there's a max of 5. But I haven't cached any key value pairs yet. Now, if I go to my other gateway and hit it, it's sharing that state with the other gateway. I got to go a little faster if I want to see rate limit, going up or going down, I should say in this case. And that's because of the token bucket algorithm we use and how that bucket refills. It's filling faster than I'm sending requests. But the throughput quota behaves a little bit differently. And so if I keep sending more messages, I'm getting close to hitting my throughput quota. But before I do that, let's go ahead and send a request that wants to store a message in the key value storage. Now, the response I get back from that gateway has that message. If I go to my other gateway, it has that same message. So this gateway stored this message. This other gateway is getting the same message stored by the previous gateway. So sharing that key value pair across gateways. Again, if I go ahead and do this enough times, I'm going to hit the threshold of my circuit breaker. The circuit opens. These assertions don't execute in policy, but my key value storage assertion was outside the circuit breaker, so it still does. Now, especially for embedded Gemfire, but even for external Gemfire, we don't expect you to have to, maybe even want to go to Gemfire directly to look at what's being stored in it. That's kind of meant to be, hidden behind the gateway's use of Gemfire and transparent to you, but you can, right? And so what I'm going to do now in this environment is I'm going to exec into one of my locator pods that's running to use the Gemfire CLI tool, GFSH, I think we like to call it GFish. So I'll make that connection. Once it connects, well, once GFish has been launched, I need to actually connect GFish to a locator. In this case, I'll connect it to the locator that I exec into. Now I'm connected to that locator. So now I could use GFish commands to, for example, not do that again, but list regions. Again, we automatically create different regions configured with different default redundancies for those different purposes that those regions will be used for by the different assertions that we demonstrated. I can also start to query some of the data that's being persisted in those regions. And I could go through and query each of those regions. And the data is going to look different depending on which assertion is persisting what data in the region, also how long it took me to get to this point, and whether that data has actually automatically expired itself based upon the assertion and defaults that we've configured. But you can actually see now that I'm connected to Gemfire, I'm looking at the data in Gemfire, and just like the gateways would connect to that Gemfire to share that data. That's the end of the demonstration. Looks like we left some time to open it up for questions to either John or me, frankly. So I guess we can look to see if anybody's been posting questions. Otherwise, you're welcome to come off mute now and ask questions if you have them.
Yeah, there have been quite a few that have come in, Ben, but I believe John has answered them.
I've answered some of. Oh, sorry, Pam, go ahead.
There are 2 or 3 that I think you need to answer, Ben. Do you see, they're from John Shintz to begin with. Basically, he's saying layer 7. It's a layer 7 question. Your slide mentioned a tactical assertion for Gemfire support. Can you detail that tactical assertion?
Sorry, I was trying to pull out my questions so I can read them too. So I didn't quite hear you. I think I see your question now. A tactical assertion for Gemfire support. Can you detail that tactical assertion? Yes. So we've long had, as probably many of you are longtime Layer 7 customers, you're familiar with tactical assertions that we have long had since Layer7 was a private company, and we had a smaller tactical engineering organization that would create custom assertions for one or more customers. They kind of fell into a category of their own. They aren't productized and automatically included with gateway releases. You would have to become aware of them in some way, ask to have access to one. We would share it with you. You'd have to deploy it to your gateways. One of those tactical assertions, one of the ones that was most used amongst them, was a remote cache assertion. And it's been around for a very long time, and it essentially allowed you to save key value pairs in a remote cache, including Gemfire, but also including others like Terracotta, Coherence, Memcached, and Redis, and possibly some more. That is a completely separate assertion with its own implementation that has nothing, that has no implementation overlap with any of these other things we've been talking about. The idea is this new key value storage assertion that's going to be available, that is available now in the gateway out of the box, and can be used with Gemfire, Redis, and Hazelcast, is meant to be an alternative to that tactical remote cache assertion. So I hope that answers your question. Any other?
Go ahead.
I was going to ask Pam, any other questions that were?
Yeah, what would be our options for embedded and multi-site?
None. We won't support multi-site on embedded. We also are again going to caution you, embedded Gemfire is an adequate alternative to replace embedded Hazelcast for the few use cases it has supported up until now. We're allowing it to be used with everything else, but remember, it's sharing resources with your gateway. And so we don't expect it to be a suitable, Gemfire deployment option for most of those use cases at scale. And so if you over rely on Gemfire and use it for many things and you start to have performance problems, we're going to tell you go to external Gemfire.
Okay, and then there's another one. How are we counting cores when using the embedded Gemfire?
There is no restriction on the use. There's no Gemfire restrictions on the use of embedded Gemfire. So there's, like I said, there's just implementation and scale restrictions, right? And what we'll support depending on how you're using it. So every gateway includes embedded Gemfire, and you can choose to use it in some or all of the ways it supports. It shares gateway resources, right? So it's effectively sharing the gateway's processing cores, but we're not counting them up and limiting you to 32. That only applies to external Gemfire.
I think that's all the questions. All the other questions have been answered by John. Just a reminder to everyone, you can come off mute if you'd like and ask questions directly. And while we're waiting, John, did you want to maybe go over some of the questions just for the benefit of the people who haven't seen these questions?
Yeah. So there was a question around having a multi-key value pair for more of a document-based lookup. And so the answer to that is like not directly. So Gemfire is a key value store. So when you put a value in, it's one key to one value. However, because it's an object value store, you could, like one pattern you could use is you can have like one key that maps to a list, right? And then you can get multiple values from that. But Gemfire, I also want to say, Gemfire also does support the storage of JSON documents as well. So there is that, that pattern that you can use. And then the follow-up to that, oh, sorry, go ahead.
No, I was just saying, great from a general Gemfire capability perspective. Remember, we're using Gemfire to support those different assertions, and we do that in very specific ways. However, if you're a customer that says, hey, I also want to use Gemfire together with my applications, so my applications and Layer 7 are both connecting Gemfire together, either to share data or you just want to otherwise use Gemfire, then what John says starts to make more sense. But again, remember, you'll have to come back for additional Gemfire licenses if you want to use Gemfire that way.
And then there was another question, and Ben, you can correct me if I answered this incorrectly, but the question was a follow-up to that multi-key value question around, is it possible to update a key value pair and update it with additional data at a later time? And they said in Layer 7, I could see doing that through a lookup, remove, add, but that it might cause latency. And my response was, in Gemfire, you overwrite the existing value in memory. So when you do like a region.put, it replaces the current value under that temporary key or whatever that key is. I don't know if that's different in Layer 7, but.
No, it's the same way we would behave. You basically just, use the store key value assertion with the same key but new data, and it'll overwrite the existing.
Okay.
So if you
and
wanted,
then there was one. Oh, sorry, go ahead.
If you wanted to make an additive change and you didn't have the existing data, you'd have to first do a lookup, add the data you want to what's currently there, then store all of that again to the same key. Go ahead, Jim.
There was one more question that came in, and I'm not sure who this is for, but I'm going to let you answer it. This is, do you have any benchmarks available or that can be requested via support?
Yes, not formalized benchmarks like we provide for major gateway versions, but we have some engineering benchmarks that we could share on demand. Both from a Gemfire perspective, because Gemfire does have a similar benchmark, but also from a Layer 7 perspective for using these different assertions on top of Gemfire. I'll just caution you, like even our more formalized benchmarks for major gateway releases, they're very objective for exactly what we did in the environment we did it in, but they don't extrapolate well to the performance you're going to expect to get in your environment with your configuration and your use cases and your volume of traffic, right? So don't over rely on benchmarks. You should always be doing your own performance testing, and that's going to be especially true if you use these Gemfire capabilities. There might be a reason you need them functionally, but you also should be doing performance testing to understand the performance impact on your gateways when using them. In some cases, you're going to want to use this because you're going to get way better performance. That's definitely true of the apply throughput quota assertion than if you're just relying on the database or Hazelcast, for example.
And we are at the top of the hour, so I don't think we're going to have time for additional questions. I want to thank everyone, though, for coming and remind you that there is a recording of this and it will be available on our Layer 7 YouTube channel. And we hope to see you next month, November.
Yeah. Thanks, Pam. Thanks, John. Thanks, everybody, for attending.
Thank you.
Thanks, everyone.